The normal random variable y has an expected value of 97 and a standard deviation of 10. Find the probability that y takes on a value between 83 and 104. So let's draw a little bit of a picture to try and understand what's going on here. We've got this y, this normal random variable, and we're told its expected value, but expected value is just mean, is 97. And we've got a standard deviation, which sort of tells us how wide the bell curve should be, of 10. And we want to find the probability. Probability and area are linked, remember, that y takes on a value between 83 and 104. So we want this area in here. Okay, we'll just double check that these are the right numbers before we keep going. 83, 104. Yep, okay, everything's good. So how do we handle something like this? Well, remember what we saw in the lesson. When it comes to any other normal random variable, the process is you've got to change it into an area in terms of the standard normal. Okay, so what we're going to do is we're going to change these values, these sort of little x's that we compare, or not little x's, I guess little y's, technically, because our random variable is y, into z-scores, which I guess we'll call A and B, and so that we get the same area, but now it's a range of values for the standard normal to take on. So how can we do this? How can we transform and take our 83, turn it into this A, and this 104 becomes B? What do? Well, the same thing we've always done, just now we're doing it twice. You take the value you compare to, okay, x or little y or whatever you want to call it, and you do x minus mu over sigma. Well, we've got the mu, we've got the sigma, and that will give us corresponding values to compare the standard normal to. So instead of x, we can use y's, and instead of z's, we'll have two different ones, so we'll say A and B. But x minus mu over sigma. Your little x, the value you compare to, the bigger one now, minus mu over sigma. So that'll be negative 14 over 10, so that'll be negative 1.40. That's the smaller of the two z-scores. And then 7 over 10, 0.7 is the bigger of the z-scores. So the probability that we want, that y is in this range, is the same as the probability that z is in this range. So now this reduces to a problem that we've been able to solve previously. Break this up into the difference of two probabilities. And we just have to solve these. Now the first one, the probability that z is less than 0.7, is something that we can easily look up in the chart. Okay, so that'll be 0.70, so that's 0.7580. .7580, and then we have to subtract off, and we're going to have to do a little bit more work here, the probability that z is less than negative 1.40. So we'll come back to this. Okay, we'll put it back in, but we got to calculate it now. So what are we dealing with? Well, we're dealing with a negative z-score, and the area is shaded to the right. Every time I see a negative z-score, my instinct is always flip it over the y-axis. So we get the same area, but now it's shaded on the right, because it flips from being on the left. And our z-score is now positive. It's 1.40. Okay, so the probability that z is less than negative 1.40 is the same as the probability that z gives us a value greater than positive 1.40. But that's not something we can look up in the chart. It's got to be a positive z-score, and area has to be shaded to the left. So we do 1, the total area under the shape, minus the area to the left. And that's something we can look up. And we just go back to the chart and look up 1.40. So 1.4, and 100th digit is still 0. So 0.9192, we're going to take that away from 1. 9192. And you do a little work and you see, oh, that's 0.08. So that now gets put in here. And we can finally finish off the question. So the probability that y takes a value between 83 and 104 is 0.7580 minus 0.0808. And I might be able to do that in my head, but I don't want to risk it because I want to get the appropriate marks that I deserve. So borrow a 10 minus a 7, 10 minus an 8 is a 2, 7 minus 0 is 7. Borrow to make a 15, 15 minus 8 is 7, and 6. So our answer here is 0.6772, almost a 2/3 chance that y will take on a value in this range. Okay? Now, it was a longer question, but the main elements from our lesson were still there. You've got a non-standard normal random variable. It's being compared to other values to make a probability. We use this z equals x minus mu over sigma to change these compared to values into z-scores. And then we have reduced it to a problem from previous lessons that we just look up in the chart.